Okay, everyone, we are going to classify some figures together, and we're going to start pretty slow, and we're going to classify our first figures into category of polygon and not polygon. So the first thing you need to know is, what is a polygon? Hopefully you're thinking to yourself that a polygon is a closed two-dimensional figure with straight lines. So let's look at A. Is A a polygon? Is it closed? Yes. Does it have all straight lines? Yes. Is it two-dimensional? Yes. So A is a polygon. So A would go in this box here, and my boxes are kind of small, so we're going to have to fit them in there. B, where would B be? Correct. It is a polygon. It is closed, two-dimensional, straight lines. How about C? Yeah. D, closed, two-dimensional, straight lines. Very good. Go ahead and finish E, F, G, H, and I, and then hit play again to see how you did. Hopefully, you put E, F, G, and I in the polygon category. The only one of these that are not a polygon is H. A circle is not a polygon. It's closed, it's two-dimensional, but it does not have straight sides. So H would be not a polygon. Now, let's move to our next category, which is quadrilateral, not quadrilateral. Now, you need to remember the word quadrilateral means. Quad, if you remember, means four, correct? So a quadrilateral is any four-sided, four-angled objects. So here, I'm going to start with just counting my sides. Is A a quadrilateral? Let's count them. 1, 2, 3, 4 sides. So A is a four-sided, four-angled object, so it's a quadrilateral. What about B? 1, 2, 3. B is not a quadrilateral. B is a triangle. C, 1, 2, 3, 4. Four-sided, so C is a quadrilateral. What about D? Let's count it. 1, 2, 3, 4, 5. D has 5 sides, not 4. So D is not a quadrilateral. Do you know what D would be? What shape is D? Hopefully you said pentagon. Very good. Let's go to E. You make the lines this time and you count. Hopefully you counted 4, and E is a quadrilateral. How about F? Quadrilateral. G? Hopefully you counted 6, and that is not a quadrilateral. G is a what? Hexagon is hopefully what you said. What about H? H is not a polygon, so it's not going to fit in any of these categories, so we would not even consider H. What about I? There's 3, so it is a triangle. So the quadrilaterals are A, C, E, and F. The not quadrilaterals are B, D, G, H, and I. Good. Let's move on to our next category. Okay, we are now going to move along and skip down to opposite sides are parallel and has at least one pair of opposite sides that are not parallel. So we're going to look. So let's look at A first. Where's A going to fit? A is going to fit into, well, is this side parallel to this side? Are these lines equal distances the whole way? No, it's not. In fact, if you were to continue them, eventually they would meet. So A has at least one pair of opposite sides that are not parallel. All you have to do is find one. But if you look here, this side here is parallel to that side there. Move on to B. B is a triangle. So if you look at this side right here, can we say it would be parallel to this side? No, it's intersecting. Parallel also has to be opposite is what we're looking for. So the opposite side to that, I would guess, would be this side, if you wanted to call that opposite. And it is obviously intersecting. So B would fit here because it has at least one pair of opposite sides that are not parallel. C. C is a quadrilateral. It has a side here. Its opposite side would be here. Would they be parallel? Yes, because they're equal distance. Let's look at the sides here on this side. The bottom side here has an opposite side here, which are parallel. So that makes C having opposite sides that are parallel. Good. Look at D. D has a side here, which is opposite would be here. Are those parallel? Are they equal distance from here to here? Is that equal distance then from here to here? No, they're not. So those sides are not parallel. Let's look at here at the top of our pentagon. Those intersect, not parallel. So we already know that D is here because it has at least one pair of opposite sides that are not parallel. What about I? I, again, is a triangle. We have this side would not be parallel to this side, and this would not be parallel to anything either. So I would be in the same category. H. H doesn't even have sides. There's no sides there. So it doesn't fit in either one of these categories. I'm going to put H over here, totally out the box, because it doesn't even go. How about E? Okay, E is kind of tricky because it's slanted. Does this side, which is opposite here, would those two be parallel? The key is, are both lines equal distance from the top to the bottom? Now, if you're not sure if they're equal distance, what can you do? You can take your ruler and you can measure. Now, if you measure from this side to this side, it is about, for me, and it's hard because mine is not to scale to yours, mine is about a little under 2 inches. Let's look at the top. Is it about the same? It's exactly the same, a little under 2 inches. So I can say that E all the way up on these sides, those sides are equal distance, so those are parallel. What about from here to here? Again, change my hand tool. From there, again, we need to look at the ruler. We need to turn it. We need to check about the distance between the two. So from this line to this line, it's about 2 1/4 all the way on that line, which means that those are also parallel. So E would fit into this category. I seem to have lost all my letters, so we need to go back and add them. A was not parallel. B was not, I had one side that's not parallel. C, both opposite sides were parallel. D was not. I was not. Didn't lose our H. E we have. What about F? F is a rectangle. Hopefully you know that a rectangle has both sides are opposite or parallel. It's also known as a parallelogram. F. What about G? Does G have any opposite sides that are parallel? What about this? Is that side parallel to that side? Are they equal distances? If you're not sure, you should check. Let's look. Is that equal? Yes, it is. So that is definitely parallel. What about any other sides? Look right here. What is the opposite of this side? The opposite of this side would be straight across from it. Now, straight across we have two sides, but opposite from this is going to be directly straight across, which would be right here. That is the opposite side. Now, are those parallel? This trips up a lot of people. So we're going to use that ruler again. We have to turn it, and we need to go ahead and measure the distance between the two lines. And I have so much green on here, it's going to be hard to see. But is it all the way the same distance? Yes, it is. So those sides are also parallel. We're not done. We have two other sides. That would be here, and the opposite side is the one straight across from it, right across here. So we have this side and this side, which are also parallel. So all the opposite sides for G are parallel. That would go in that category. And we're done. Now, let's go see if all sides are congruent or all sides not congruent. We are going to be using two different tables here because it would make sense to do these at the same time. The top table says opposite sides are congruent and not all sides are opposite or congruent. So we're looking for two different things. So first, if not all sides are opposite or congruent, we can fit those into a category right now, right? So which ones have not all sides are opposite or congruent? Well, obviously a triangle is not going to have all opposite sides. So we can automatically put B and I in that category here because they don't have opposite sides, right? What about H? No. That's not going to, that doesn't even have sides, so it's not opposite or congruent. D is also another odd figure. This does not have an opposite side that could be congruent, so we can put a D here. The rest, I believe, have opposite sides. Now, the question is, are they congruent? Now, what does the word congruent mean? The word congruent means same, which means if we're looking at a side has to have the same length. It could be a vertical line and a horizontal line. They could both be congruent. Just because they're going opposite directions doesn't mean they're not. If we have a 3-inch horizontal line and a 3-inch vertical line, they would be considered congruent sides because they're the same length. So let's quickly go and look for the congruency of all the sides. Now we're looking for opposite sides now and all sides. Those are the two categories we're going to look for. So you're going to need your ruler. Let's go ahead and use our ruler and measure A. A has, this side is about 2, and so is this side over here, I believe. Now, mine's going to be different because I do not have the same scale as you do, as I've said before. Those opposite sides are congruent, but look at the bottom and the top. Here and here, obviously different sides. You don't even have to measure that to know that all sides are not congruent, so A would go here. And not all sides are opposite or congruent, so that would be A would also be here. Okay, look at B. We've already taken care of B. So where would B go for in this bottom box for all sides are congruent? We already know that they don't all have opposite sides, but that doesn't mean they're not all congruent. Go back to my pen. Okay, so let's go ahead and measure. This right here would be about 2.5, it looks like. Yes, I'm doing the best I can with my online ruler. It's hard to use a ruler on a iPad like this. And this is about, looks like 2.5 again. But this one is not quite 2.5. That's only like 2.25, which means B has 2 equal sides, which is an isosceles triangle, which is going to put us in what category? All sides are not congruent here because the bottom one was a little bit smaller than the 2 sides. Look at C. C is a rectangle or a square. We all know that. Now, if it's a square, it's going to have all equal sides. So let's see if C has all equal sides. That's about 2.5 for me. That's about 2.5 for me. So far, those two opposite sides are congruent. This one is about 2.5, which means this one has to be 2.5 because by definition, it has opposite sides or the same. So C is a square. All sides are congruent and opposite sides are congruent. What about D? We've already said there's at least one side that's not opposite, but that doesn't mean that they're not all congruent sides. Maybe every single side is congruent. So let's go back and find out. Here we go. We have, that's about 1.5, if I'm not mistaken. That's about 1.5. That's about 1.25, which means that D is going to fit where? All sides are not congruent, and we already have the opposite there. Look at E. E, again, is a quadrilateral, 4-sided figure. We already know that it has opposite sides are parallel. So, but that doesn't mean they're congruent. We know they have opposites, right? But that doesn't mean they're congruent. So let's go and find out. Here we go. Right here, that is almost A little less than 2 there. A little less than 2 there. We know the opposite sides are going to be equal as a definition there. And I believe this would be called a parallelogram, right? It's a parallelogram because it has that slant and it forms acute instead of right angles. That is not the same. So that is going to be E here. And where would E go here? Not opposite sides are congruent, definitely, because if we go back to this one, this is going to be equal to this one, but the two other ones are going to be equal to each other, so that would go in that category. F, another rectangle. We know it's not a square because we know that this side, opposite sides are going to be equal. That's the definition of a rectangle, and this opposite side is equal to that. We know that already. So without even measuring, you already know that all sides are not congruent. You can look at that and see. But we do know the opposite sides are congruent, so that would go in that category there. Now what about G? G's that tricky one again. So let's see. We have about 1 1/4 here, about 1 1/4 here, 1 1/4 here, 1 1/4 here, 1 1/4 here, and then our last one, 1 1/4. So to me, G looks like all sides are in fact congruent. Are the opposite sides congruent? Yes. So that would fit in these two categories. Nice. H is not going to fit because there's no sides, so I'm not even going to put that over there. I'm going to go throw H over here. Really, I guess we should have taken H and put it on the side over here too because it doesn't even have sides, but I guess that's okay. We have one left to pick, and that is going to be I. So we can already tell that I is not going to be an equilateral triangle because look right here. That is a little less than 2. I have a feeling this is going to be more than 2. Now, if you can't look at this and see for sure, you definitely need to practice. Look, this is going to be almost 3. So we know right now that all sides are not congruent, right? And now all sides are opposite or congruent for I. I put an 8 there. I need to put an I, excuse me. And we already know that other one answer. So let's move on. Out. Okay, we're going to move back up to right angles. And we're going to notice that we're either going to have all right angles or they're going to include angles that are greater and or less than 90 degrees. Now, there's a lot of different ways to do it. I just need to know if they're right angles or not. So I don't really need my protractor. I can really just use any kind of angle checker, which is a corner to anything. And I'm easily just going to take these and I'm going to be putting this in the corner and checking. So is this right here a right angle? Line that up. No. So we already know that A is going to fit and includes. We are probably going to be able to do the same thing for B because look right here. If I line this up, it's obviously got an acute angle there. So B is going to fit here. C. Again, if you know the definition already for a rectangle or a square, you know that it has 4 right angles. There's really no reason to check it if you know that definition. Now, if you're not very sure about that definition, you're definitely going to want to check, and it doesn't hurt to check. I would check rather than guess because you have the tool and you should use it. So that's a right angle, that's a right angle. I'm going to put that right up there to make sure those lines match up, and they do. That's a right angle. So here goes C. And I know F is going to be the same way, but I'm going to prove it to you because math is all about proof, right? Here. 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 And there. See? All right angles. Now, I skipped D, which let's go ahead and pull this up for D. What do you think? Most of you are getting really good at this, so you can tell that right there is already a what? That is an obtuse. So all you have to do is find one because it says all. So once you found the one that's not, you can go ahead and mark that down. What about E? E is a quadrilateral, but it's a special quadrilateral. It has two parallel sides. Two pairs of parallel sides, but they're not 90-degree angles. They are different than 90-degree angles, which that is an obtuse angle, which makes this going to be a different answer. So we're going to put E right over here, not with the rectangles in the square. What about G? G is going to have an obtuse angle right here. There you go. So that's going to make G in this category as well. What about H? H has a lot of angles in it. It has 360 1-degree angle, and we're not going to be able to do a right angle there, so that is absolutely going to be here. And I do see a right angle, I believe, in I. This right here makes a right angle, but let's look at this top one. That is an acute angle. So I fits here. All right. And that's how you classify figures using different types of properties. You're going to move on to your next task. You have a choice from A or B. Look over both choices, choose carefully, and then you'll be ready to, after you do that task, to move on to your exit ticket. Have fun and good luck.